guys, welcome to this set of videos. What we're going to do is we're now going to start talking about the topic dealing with figuring out whether triangles are congruent. Now, this idea of congruency is something we've been looking at now for a few chapters here in geometry. And specifically, what we're going to do here in this set of videos and the notes here for the next several sections is deal with triangle congruency. So exactly how can you go about showing or proving that two triangles are congruent? Now, we've talked about the idea of shapes being congruent. Here's what we said, just real quick refresher before we sort of jump into this section. We have this special notation for congruence. It is both an equal sign along with, oh, hang on, my equal sign got a little weird. I want it to look like an equal sign. There's my equal sign, and then I got this little squiggle that we put above it, right? And remember that that symbol means congruent. And congruency tells me two things, right? So in algebra, anytime we put an equal sign into a problem, what we're saying is that those two things have equality. They have the same measure, they have the same size, they have the same magnitude, right? Something like that, like x is equal to 4, or we say that pi is equal to 3.14, right? Just telling you what it's equal to, what is its magnitude, right? What is its value, okay? But in geometry, we have to go a little bit further than that. So in congruency, when we're talking about something that is congruent, we still have the equal sign because congruent does mean that two things have the same magnitude or the same measure. So we say that two things have the same measure, just like we mean in algebra when we use an equal sign. But we have to go a little bit further than that. In geometry, we're generally going to be talking about shapes. And so it's not just enough to say that the shapes or that objects have the same measure, right? But in order for them to be congruent, they must also have the same shape. And that's what that little squiggle above there means in the congruency symbol. It tells me that the objects I'm comparing also have the same shape. So again, we've been talking about congruency for a while now, and here in the next several sections, we're just going to apply it primarily to triangles. So like we always do, we start a new set of videos and a section of notes. We need an essential question. This is the question you need to be able to answer by the time we get to the end of this set of notes and these videos. And what we're going to do is, can you show that two triangles are congruent? And what ways can we use to show that triangles are congruent? And that will be the theme you're going to see here over the next several sections. How can we show or prove that triangles are congruent? Our essential question. Well, in order to answer that essential question, there's several things that you're going to need to know or be able to do. So here's our objectives. First, you'll need to be able to determine if triangles are congruent. We'll show you how to do that. Then once we know if triangles are congruent, we can use that information to find missing angles or side lengths. All right, and we'll go through all of that. So let's just jump right into it with a really, really important idea here in geometry, and it is this gigantic mouthful right here: corresponding parts of congruent triangles are congruent. And because it is such a long term, we break it down to an acronym: CPCTC. CPCTC. Corresponding parts of congruent triangles are congruent. CPCTC. In fact, let me go ahead and underline those so you see where they're coming from. There's my CPCTC. Corresponding parts of congruent triangles are congruent. Essentially, here's the idea. I've got some stuff here as far as corresponding parts of congruent triangles and its converse statement, but really what it is written right here for you. So let me go ahead and highlight this. This will be really sort of the most important part, and then we'll show you exactly how it works in a couple of example problems. But here's what this means. Two triangles are congruent. That's what we're trying to show. Over the next several sections, you're going to see this theme. How do we show that triangles are congruent? Well, I can show you two triangles are congruent if and only if. Please notice how this is a biconditional statement. If and only if, right? If and only if corresponding pairs of sides and corresponding pairs of angles are congruent. Here's all this means. You need to be able to show that in two triangles, you have three pairs of congruent sides. Meaning you have two sides that are same length, you have another two sides that are same length, and a third two sides that are the exact same length. And then you need to be able to show, right, that two of the angles are the same, and another two pairs of angles are the same, and then finally that third pair of angles is the same, right? You just have to show that everything, corresponding pairs of sides and angles, are congruent. If you can show that, then the triangles must be congruent. It's actually really not too terribly difficult an idea, so let me show you how it works. I've got for you here an example where I've given you two triangles, and I just want you to determine whether the given triangles are congruent. So let's go ahead and do that. In order to show that the triangles are congruent, CP, CT, C. In fact, let me write it right here, CP, CT, C. I need to show that the corresponding pairs of congruent triangles are congruent. Let's see if I can do that. I take a look at these guys right here, and well, here's what I see. In red, go ahead and take a look at the sides. I see that this side right here, GH, is congruent to this side, LK. How do I know that? Well, they both have the same measure, 1.7 meters, 1.7 meters. Let me write that. So I have this segment, GH, is congruent to the segment, LK. Fantastic. Let's keep going. What else do I see here? Oh, I see right here, GH is congruent to LM. How do I know? 1 meter, 1 meter. They both have the exact same measure, so that means that JH, that segment, is congruent to LM, segment LM. Fantastic. Keep going. Well, look at that. JG is 2 meters and KM is 2 meters. That means that those two sides are congruent, and I can say that JG is congruent to KM. So far, we're off to a great side. In order for CPCTC to work, I have to show, right, that the pairs of corresponding sides are congruent. Well, so far I've done that. These two are corresponding sides, and they're congruent. The green ones are corresponding sides, and they're congruent. The blue ones are corresponding sides, and they're congruent. So far I'm off to a great start. But it's not just the sides, I also have to show that the angles are congruent. Well, let's go ahead and take a look. My congruent angles are going to be, oh, look at this, right angle H and right angle L, right? Well, those guys are definitely congruent. They're both right angles. I'm told that right in the problem. You can see that little right triangle symbol in there. So that means that angle H is congruent. Oh, I was about to put J, and it's actually angle L. So far we're off to a great start. Let's see what else I can find. Well, angle G and angle K are corresponding angles, right? Corresponding angles, do they have the same measure? G is 30 and K is 30. So in fact, they do. I'll put the little double arc in there to show that those are my corresponding angles, and they are congruent. G is congruent to angle K. They both have the exact same measure, 30 degrees. One more angle to go. Right here, J is 60. Its corresponding angle in my other triangle is M, which is also 60. And so just like that, 3, 1, 2, 3, I see that angle J is congruent to angle M. And cuckoo cuckoo, I have now shown that all three pairs of sides and all three pairs of angles are congruent, which means these two triangles must be congruent. So the conclusion then is that triangle, let's go JHG, is congruent to triangle LKM, right? I know that these two triangles have to be congruent because I just showed all three pairs of sides are congruent and all three angles are congruent. And so CP, CTC, corresponding pairs of congruent triangles are congruent. This theorem tells me those two triangles must be congruent. That's how this works. Let's try another one. Let's see here. Well, in order to line these triangles up, I'd have to flip this guy over and slide him in. So that means then that AB would have to be the corresponding side of ED. 12.1, 12.1, we're looking good. Those guys are definitely congruent. So segment AB is congruent to segment ED. Again, if I take that guy and flip it over and slide him right on over here, that means then that side AC would have to be congruent to side DF. And look at that, 7.9, 7.9. Awesome. Those are the exact same measure. These two sides are congruent, and so AC is congruent to side FD. Fantastic. One more side to go. I have side CB, which must be congruent to its corresponding side EF. CB is 8.5, EF is 8.4. Oh no, no, we did not get it. CB does not equal segment EF, not equal, which means I do not have, right, corresponding pairs, right, of congruent triangles are congruent. Well, these are not congruent. So what does that tell me about these two triangles? They are not congruent. These triangles are not congruent. Alright guys, this is how it works. Again, real quick, all you need to do, CPCTC, corresponding pairs of congruent triangles are congruent. Show, right, that the corresponding sides are congruent. Show that the corresponding angles are congruent. If you can show both of those, sides are the same, angles are the same, then you know the triangles must be congruent. Head on over to the next page of the notes. We'll take a look at a few more of these problems. I'll meet you guys there.